So, hello, VC students. My name is Brian Hutchison. I'm a professor here at Victoria College, and today we're going to tackle a word problem. So, some background about this word problem is it's really just using simple interest. Interest is equal to the principal times the rate times the time. Okay. I like to call it I par T, if you take out all the vowels. I par T, like making money from interest. So let's say that you won $50,000. Okay. You won $50,000, and you know better than going out and blowing that on fun stuff, right? Maybe just a little bit of fun stuff, but not a lot of fun stuff. Okay, but you won $50,000. Okay. You split the winnings into two accounts. One earns, let's say, 8%. And the other 4%. At the end of the year, you make $3,200 in interest. So this still isn't a word problem. There's no question, right? But it basically tells us what's going to go on. Right? You got $50,000. You're going to separate it into two different amounts. You put one sum into the 8% account, and then you put the rest of it into the 4% account. Right? In 1 year, at the end of 1 year, you have $3,200 in interest. So the question is, how much did you invest in each account? So what do y'all think? Is there a way to tackle this? Is that the only formula do I need? I will tell you there's technically another formula. A part plus the other parts must equal to my whole. Right. But the way I like to tackle this one is, the principal, the amount that you invest, times the rate, times the time, has to spit out your interest. This is a chart, and the problem with word problems is, they've got words in them. We got to organize it. We got to make it make sense. So the nicest thing is, it said that it was 1 year. Perfect. The other easy thing is, we know one is 8% and the other one is 4%. But now comes the true question, right? The P column and this I column, right? What in the world do we put there? Well, when we start dealing with the variable, it's always nice if the variable answers the question, right? So how much did I invest in each account? Okay, so we're going to use X. Do I know how much I put in the 8%? And the answer is no. Well, if you don't know, that is a perfect place for your X. And that X helps answer the question. So how much did we put in the 4%? Can I just use X again? Well, you can't use X again Just, you can't. Unless it said I evenly split up the $50,000, but that's boring. That's $25,000 in each account. Mm-hmm. So what has to happen is basically we have two sums of money, right? Two pieces of money that sum up to $50,000. Right. Well, so there's this some other amount that I need to know. I put X in the first one. How much is in the next one? Oh, you subtract X and subtract X. The second account has to have $50,000 minus X. X plus the $50,000 minus X. X and minus X cancels out. Leaves me $50,000. Those two parts have to add up. Well, I'm really not going to worry too much about multiplication by 1 year. So my interest is just, well, it's my rate times the principal, X. This one is the rate times the principal of $50,000 minus an X. What is this box? This is the interest that I made for my money that I put into the 0.08 account, the 8% account. What is this other one? It is the interest. It is the interest that I put into the account that was at 4%, or the 0.04. There's one piece of data we haven't used, right? So all this thing did was it filled in some gaps. The chart helped me see a possible solution. Well, what is that solution? The interest in the first account plus the interest in the second account has to be equal to my total interest made for that year, which was $3,200. So sometimes what we see is we saw them call that an annual income, right, that you made off the account. And now we just have a nice little problem that we need to solve. This will help me solve for X. And I don't know about you, but I actually love fractions a heck of a lot more than I love decimals. Now, mind you, we have calculators. We can easily do this, but I do want to show you an easier way. So, in 2.1 and 2.2, earlier on in Chapter 2 for college algebra, in 303, y'all will also do this problem, and it's honestly not a bad problem for certain things in 1332 either. Anything that touches finance, but it's just simple interest. But I have the right to multiply through, right? If I can multiply through by a number and get rid of all the denominators in an equation, well, can I get rid of all my fractions too? And the answer is yes. I'm going to multiply this piece by 100. I'm going to multiply this piece by 100, and I'm going to multiply this piece by 100. Basically, I'm multiplying through by 100. And what does that do? It moves my decimal. So instead of 0.08, I now have an 8x plus 4 times 50,000 minus x. And this is 3200 with another 2 zeros. No more dang decimals. So 4 times 50,000 is 200,000. That becomes a minus 4x is equal to 320,000. Combine my like terms. 8 chickens minus 4 chickens gives me 4x plus 200,000. is equal to 320,000. Opposite of addition is subtraction. This leaves me with 4x is equal to 120,000. Divide by 4, and I get x is equal to 30000, which comes out to $30,000. That's still not answering my question, though, right? You always got to make sure you're answering your question. So if I scoot back up, so x is 30,000. Remember, this is a video. Pause it, rework it 1,000 times, right, until you see the pattern. But basically, if I go to blue, it said that x is $30,000. So in the 8% account, you put in $30,000. In the 4% account, guess what happens? Well, it's $50,000 minus $30,000, which is $20,000. So the 8% account got $30,000. The 4% account got $20,000. And we solved the question. So some things you got to be careful of. Some people want to put, well, can I let the second principal for the 4% be y? That's my next video, folks. All right. Right now, most of y'all do not know how to solve it. It's not until the end of college algebra where we really learn and worry about systems. Right? But this is a nice, neat way, but it really does hinge on the fact, well, if you put X amount of dollars into one account, the total minus X has to go in the other account. It's a good word problem. It's a good setup. It shows the chart. Doing mixtures is very similar to this. There's a little change in the rows and columns, but the logic behind it is very similar. So charts help. They turn the nasty words into just numbers, and we just need a few equations to help us along the way. But other than that, I hope you have good luck in tackling your word problems, and have a good day, folks.